Chapter 9, Lesson 2, Lines of Best Fit. You will be able to draw lines of best fit and use them to make predictions about data. When data are collected, the points graphed usually do not form a straight line, but may approximate a linear relationship. A line of best fit is a line that is very close to most of the data points. Refer to the information in the table about the cost of cookies. Construct a scatter plot using the data, then draw and assess a line that seems to best represent the data. Use the line of best fit to make a conjecture about the cost of cookies in 2013. I'm just going to make this grid a little bit bigger so I can write on it. Okay. So when we look at our years since 2000, it goes from 0 to 9, so I think it's safe to count by ones. So we would have 1, 2, 3, and just keep going until you run out of space here. So 7, 8, 9, looks like we can go to 15. Okay, and we look at our average, so this under here is years since 2000. And our y-axis will represent the average cost. Oh. Okay. It looks like our lowest number here, I have 2.59 looks like the lowest, and 3.24 looks like the highest. So I'm going to automatically put a break in this graph because I'm not going to start at 0. And I'm going to count by tenths. So we would start with 2.5. 2.6, 2.7, 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, and 3.5. Now let's plot the points. 0, 2.59, 1, 2.81, 2, 2.65, 3, 2.67, 4 is 2.88, 5 is 2.7, 6 is 2.85, 7 is 2.88, 8 is 3.17, and 9 is 3.24. Now when you're drawing a line of best fit, you want it to follow the pattern of the graph. For example, I would not by any means draw a line here because the points do not follow that line. even if I slant it this way, I still have most of my points underneath. So the goal is to get approximately half of the points above and half of the points below the line. So maybe somewhere about here. So again, you have about half above, half below. Maybe slant this down a little bit more. Okay, it follows the general trend of the points. The points are increasing and around this line. Okay, so as going forward, we can see that maybe in 13, 14, 15 years since 2000, it increases as well, the price of cookies. So there's our line of best fit. Now let's make a conjecture. We want to know in 2013. Well, the years since 2000, year 0 would be 2000, and 2013 would be year 13. So if we go up to our line, we have right here, follow it over, the price of cookies would be about $3.30. So let's jot that down. Cookies will cost about $3.30 in 2013. That is our conjecture. Letter B. Refer to the scatter plot about yearly points scored by a certain race car driver. Draw and assess the line that seems to best represent the data. Use the line of best fit to make a conjecture about the points the driver will score in 2015. Okay, so here, most of our data seems to be up here between 3,000 and 6,000. However, we have a point way down here. This right here would be considered an outlier. So when we're drawing our line of best fit, because it's an outlier, we don't really pay much attention to that. So when drawing our line of best fit, okay, let's just draw one and then we'll move it around. You want to follow the trend of the data. You want most of your data points to be above and most of your data points to be below. Let's see here. That looks pretty good. It doesn't have to go through any points, but it can. Readjust a little bit. There we go. We have a lot of the points are above, but we do have just about the same amount underneath, maybe off by a couple. So there's our line of best fit. We want to know in 2015. This is years since 1999. Okay, so in 2015, it would actually be about 14, an x value of 14. So again, if we have 1999 represents year 0, to get all the way to 2015, that would represent year 16. So we're actually looking, I believe I said 14, I meant 16. So about year 16 is somewhere, maybe about here. Follow it all the way up. Follow it all the way across. It looks like it's just under 6,000. So we can say the driver will score about 5,000, we'll say 900 points in 2015. And that is our conjecture. Equation of a line of best fit. You can write an equation for the line of best fit and then use it to make conjectures. The scatter plot shows the number of cellular service subscribers in the U.S. Write an equation in slope-intercept form, that's y equals mx plus b, for the line of best fit that is drawn, and interpret the slope and y-intercept. Use the equation to make a conjecture about the small number of cellular subscribers in 2015. Now, in order to figure out the slope of a line, or the equation of a line, we need the slope and the y-intercept. Well, our y-intercept is over here, where it crosses the y-axis. Between 75 and 100, I would say that's probably close to about 85. So that's our y-intercept. Our y-intercept is about 85. And now we need to find our slope. Remember, slope is the change in y over the change in x. But we need 2 points to use. When you choose 2 points, they have to be points on the line, not points from the data, points on the line. It looks like we have a point here, and we have another point here. And I'm looking where the line crosses an intersection on our grid. So we have these 2 points. This point here is 3,150. And this point up here is 9,275. So we'll label x1, y1, x2, y2. It does not matter which is which. So we have 275 minus 150 over 9 minus 6, which equals 125 over 6, which is about 20.83. So we have our b, which is our y-intercept. We have our m, which is our slope. So when we plug it in, so y equals mx plus b, we get y equals 20.83x plus 85. That's our equation of the line of best fit. Now it says to interpret the slope and the y-intercept. So the slope is 20.83 and represents the number of cellular subscribers that let's rephrase that, and represents the number of cellular subscribers increased about 20.83 million per year. Now the y-intercept is 85 which represents that in 1999 there were about 85 million cellular subscribers. And the last part of this is to make a conjecture using our equation of subscribers in 2015. So again here in 1999 is year 0, which means 2000 is year 1. Skip all the way to 2015, that would be year 16. So our x value is 16. So let's take our equation and plug in 16. 20.83 times 16 plus 85. Plug it in the calculator and we would get 418.28. So the conjecture is in the year 2015 there will be about 418.28 million cellular subscribers. The scatter plot shows the graduation rate of high school students. Write an equation in slope-intercept form for the line of best fit that is drawn, and interpret the slope and y-intercept. Use the equation to make a conjecture about the graduation rate in 2020. Our y-intercept is just under 60, so I would say our y-intercept is 59. Our slope, which can be found by the change in y over change in x. We need to pick 2 points. I would say there's a point right here at 465, and I would say there's another point right here at 770. So our points again, we have 465 and we have 770. Label x1, y1, x2, y2. And let's plug them in. 70 minus 65 over 7 minus 4, which equals 5/3. So our slope is 5/3, and we can leave it as a fraction. So if we have our slope and y-intercept, our equation is y equals 5/3 x plus 59. So now let's interpret the slope and y-intercept. The slope is 5/3, which is about 1.7 if we divided it out, which means the graduation rate increases about 1.7% each year. The y-intercept is 59, which means the graduation rate in 1998 was about 59%. Now let's use our equation and make a conjecture in the year 2020. Well, this is years since 1998. 1998 would be year 0. 1999 would be 1. 2000 would be 2. So all the way up to 2020 would be year 22. So our x value we are going to plug in is year 22. So our equation, y equals 5/3 x plus 59. Let's plug in that 22. Y equals 5/3 times 22 plus 59. Put it in the calculator. We get something around 96.4. So our conjecture here is that in 2020, the graduation rate will be about 96.4%.